Hello, in this lecture we will find out the area of the green shape in three different methods. In the drawing we have rectangle ABCD. We know that AE equals to ED. We also know that BE equals to 7 units and BF equals to 9 units. And also we know that angle ABF equals to angle ABE equals to theta, this angle, and angle EBF, this angle, equals to also theta, and we want to find out the area of this green shape. So we'll start with the first method. In the first method, we will extend side CD and side BE until they intersect with each other. And we will define the intersection point between extended CD and extended BE as point P. This point is defined as point P. And we actually know that CD is one side of rectangle ABCD, therefore it is a straight line. So CD or DC is a straight line, and when we extended the straight line CD by a straight line, then we will get still a straight line. So CP will be still a straight line because we extended the straight line CP by a straight line, so CP will be one straight line. And we can write down that CP or PC is a straight line. PC is a straight line. And we have a rule, and we also know that all the angles inside a rectangle are right angles. Therefore, this angle is a right angle, that is to say it equals to 90 degrees, and also this angle is a right angle, that is to say it equals to 90 degrees, and this angle, it is also a right angle, that is to say it equals to 90 degrees. And we have rule number 1. According to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. I'll repeat again on rule number 1. According to rule number 1, the sum of the angles according to rule number 1, the sum of the angles on one side of a straight line is equal to 180 degrees. So here we know that PC is a straight line, so if we focus on this side of the straight line PC at point D, the sum of the angles must be equal to 180 degrees. So here we will define angle PDE, this angle is angle X, plus this angle that is a right angle. The sum of those two angles must be equal to 180 degrees according to rule number 1. So you can write down that angle X plus the angle that equals to 90 degrees, the sum of those two angles must be equal to 180 degrees according to rule number 1. And we will subtract 90 degrees from this equation, and we will get that angle X equals to 180 degrees minus 90 degrees. That is to say, angle X equals to 90 degrees. It is a right angle. So we can substitute X by a right angle because it is a right angle. So we know that PC is one straight line, and this is also a straight line, and we have the rule that the opposite sides of a rectangle are parallel to each other. That is to say, AB is parallel to DC. So AB is parallel to the straight line DC. But we know that DC and PC lie on the same straight line. Again, DC and PC lie on the same straight line. So if AB is parallel to the straight line DC, then AB will be also parallel to the straight line PC, because of the fact that PC and DC lie on the same straight line. So AB must be also parallel to PC. So I will write it down. AB is parallel also to PC. AB is parallel to PC. And we have also rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other. I repeat on rule number 2 again. According to rule number 2, alternating angles between parallel lines are equal to each other. So here actually those two angles are defined as alternating angles and they are located between the parallel lines AB and PC, therefore they are equal to each other according to rule number 2. So you can write down that according to rule number 2, angle ABE is equal to angle DPE, this angle. I repeat again, angle ABE is equal to angle DPE according to rule number 2, that those two alternating angles that are located between the parallel lines A, B, and PC, they are equal to each other. But we know that angle ABE equals to theta. It is given us in the question. So we can write down that angle ABE equals to theta according to what is given us in the question. So for this equality, we will conclude that angle DPE also equals to theta, and angle DPE also equals to theta. Angle DPE also equals to theta. So we can write here that angle DPE, this angle equals to theta. And in the next step, we will prove that those two right triangles can go into each other. That is to say, we will prove that the right green triangle, triangle ABE, is congruent to the right green triangle, triangle PED. So why those two right triangles can go into each other? First of all, we just right now proved that those two angles are equal to each other and they are both equal to theta. So we can write down angle ABE, this angle, equals to angle EPD, this angle, and they are both equal to theta. So we found out that angle ABE equals to angle EPD, and they are both equal to theta. We also know that those two angles, they are equal to each other, they are both equal to 90 degrees. So angle BAE is equal to angle EDP, this angle, and they are both equal to 90 degrees. So we found out that angle BAE equals to angle EDP, and they are both equal to 90 degrees. And those two angles, they are vertex angles and they are equal to each other. So this angle, angle BAEB, is equal to this angle, angle PED, this angle, according to the rule that vertex angles are equal to each other. I repeat again. Angle AEB equals to angle PED according to the rule that vertex angles are equal to each other. Those two angles are defined as vertex angles, and we have the rule that vertex angles are equal to each other. And it is given us in the question that AE equals to ED. Here, AE equals to ED. So we can write down that AE equals to ED according to what is given us in the question. I repeat again, AE equals to ED according to what is given us in the question. So we actually can conclude that those two right triangles can go into each other according to angle side angle rule. We have side AE and those two angles in the green triangle, triangle ABE, can go to side ED and or those two angles and the side between them, that is side ED, in the triangle PED. Therefore, those two triangles can go into each other according to angle side angle rule. So I write it down. Triangle ABF congruent. This is the sign of congruent to triangle. This is actually triangle ABE. This is triangle ABE. Congruent to triangle PED. According to angle side angle rule. I repeat again, triangle ABE can go into triangle PED according to angle side angle rule. So what is angle side angle rule? Angle side angle rule states that if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included then the side that included in another triangle then the triangles congruent to each other, according to angle side angle rule. I repeat again on angle side angle rule. According to angle side angle rule, if two angles and the side that included between those two angles in one triangle congruent correspondingly to two angles and the side that included in another triangle, then the triangles congruent to each other according to angle side angle rule. And I will repeat shortly. And the drawing we have those two angles and the side that included between those two angles, that is to say side AE in the green right triangle, triangle ABE, that congruent to those two angles and the side that included between those two angles, that is to say ED in triangle PED. Okay, therefore, according to angle side angle rule, those two triangles congruent to each other. And because they have two angles and the side between those two angles in the green triangle congruent to those two angles and the side that included between those two angles in this triangle, therefore those two triangles congruent to each other according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that BE equals to EP. So BE equals to EP. BE equals to EP according to the rule that corresponding sides and congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the two corresponding sides, that is to say BE and EP, will be equal to each other. But we know that BE equals to 7 units. It is given us in the question. We can write here that BE equals to 7 units according to what is given us in the question, and from this equality we will conclude that EP also equals to 7 units. EP equals to 7 units. So we can write here that EP equals to 7 units. And in the next step, we will define the area of quadrilateral EBFD as Y. I write it down. The area of quadrilateral EBFD is defined as Y. Again, the area of quadrilateral EBFD, this is the sign, the two brackets is the sign for the area. It means the area of quadrilateral EBFD is equal to Y according to our definition. And we will also define the area of this green right triangle, triangle ABE, as X. So the area of the right green triangle, triangle ABE, is equal to X according to our definition. So as you can see from the drawing, the area of the green shape equals to x plus y. Okay, the area of the green shape equals to x plus y. So you can write here that the area of the green shape equals to x plus y square units. The area of the green shape equals to x plus y square units. Okay, the area of the green shape equals to x plus y square units. And we know that those two triangles can go into each other according to angle side angle rule. So if they can go into each other, they also will have the same areas. So if the area of triangle ABE is equal to x, then the area of triangle PED will be also equal to x. So the area of triangle PBF is equal to x plus y. You can see it easily from the drawing. The area of triangle PBF equals to x plus y. So actually the area of triangle PBF is exactly the same as the area of the green shape. They are both equal to x plus y square units. Therefore, we can find out the area of triangle PBF, and in this way we will find out the area of the green shape. Okay? And we know that the area, we know that triangle PBF, this triangle, it is an isosceles triangle because of the fact that it has two angles that are equal to each other. They are both equal to theta. So we can write down that triangle PBF is an isosceles triangle. Okay, triangle PBF is an isosceles triangle because of the fact that it has two angles that are equal to each other. Both those two angles are equal to theta. And we have rule number 3 that relates to an isosceles triangles. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So I will read rule number 3 again. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle, triangle ABC is an isosceles triangle. I will draw it now. we have this triangle, triangle ABC, is an isosceles triangle. So this is triangle ABC, and it is an isosceles triangle because it has two angles that are equal to each other. Those two angles are both equal to theta, therefore triangle ABC is an isosceles triangle. And the base of the isosceles triangle, triangle ABC, is BC. So if we will draw median from the vertex A to the base BC, so this is the median to the base. And we will define the touching point between the median to the base BC as point O. So the median bisects the base BC into two equal parts, that is to say BO equals to OC. So if BO equals to X, then OC will be also equal to X. This is the definition of a median, that it bisects the side that it eats. So the median AO bisects the base BC into two equal parts, that is to say BO equals to OC equals to X. But according to rule number 3, the median AO, it is not only bisects the base BC, but it is also perpendicular to the base BC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay, those two angles are right angles because of the fact that according to rule number 3, whenever you have an isosceles triangle and you draw median to the base, then that median will be perpendicular to the base. So the median AO is perpendicular to the base BC, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees, according to rule number 3. And we can actually implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle, triangle PBF. As I already mentioned, triangle PBF is an isosceles triangle because it has two angles that are equal to each other. Both those two angles are equal to theta. And the base of the isosceles triangle, triangle PBF, is PB. And the median from point F, actually it bisects the base PB. The median FE to the base PB bisects the base PB, that is to say it divides it to two equal parts, that is to say PE equals to EB equals to 7 units. But according to rule number 3, the median FE to the base PB, it is not only bisects the base PB, but it is also perpendicular to the base PB. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees, according to rule number 3. So those two angles are right angles according to rule number 3 because of the fact that the median FE to the base of triangle, the isosceles triangle PBF by say it is perpendicular to the base PB, that is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that this angle, it is a right angle, therefore triangle EBF is a right triangle because it has one angle that equals to 90 degrees. So we will focus on the right triangle, triangle EBF, and in the right triangle, triangle PBF. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, in triangle, the right triangle FEB, in the right triangle FEB, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And the hypotenuse in the right triangle FEB is BF because it is in front of the right angle. So the square of the hypotenuse is BF squared. And it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB squared plus EF squared. So I'll repeat again, in the right green triangle FEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, BF squared equals to EB squared plus EF squared. But we know that it is given us in the question that BF equals to 9 units, so BF squared will be equal to 9 squared. 9 squared is 81. And it equals to EB squared. EB is given us, it equals to 7 units, so EB squared will be equal to 7 squared. 7 squared is 49. Plus EF squared. EF is the missing variable, so we will leave it as it is. So in conclusion, we found out that according to equation number 1, 81 equals to 49 plus EF squared. We will subtract 49 from this equation number 1, and we will get that (81 minus 49 is 32). So 32 equals to EF squared. We will take a root out of this equation number 1, and we will get that EF equals to the square root of 32. (32 is 16 times 2, so I write it down. The square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2 units, according to equation number 1. So we can write here that EF equals to 4 times square root of 2 units. And now it is very easy to calculate the area of the isosceles triangle, triangle PBF. The area of any triangle is equal to the base of the triangle times the height to the base over 2 I repeat again, the area of the isosceles triangle, triangle PBF is equal to the base of the triangle times the height to the base over 2. So the area of the isosceles triangle, triangle PBF is equal the base of triangle PBF is BP, so the base is BP, the height to the base is EF, it is EF because of the fact that EF creates 90 degrees with the base, therefore it is the height over 2. So we found out that the area of the isosceles triangle, triangle PBF equals to BF times EF over 2. It is actually BP. It is actually BP. The base is BP, as you can see. The base is BP. So the base BP equals to 7 plus 7. That is to say BP equals to 14 units. So I write it down. The area of the isosceles triangle, triangle PBF equals to 14 units times the height EF equals to 4 times square root of 2 units over 2. So we found out that the area of the isosceles triangle, triangle PBF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so I write it down. So the area of the isosceles triangle, triangle PBF is equal to 7 times 4 times square root of 2. So the area of the isosceles triangle, triangle PBF, that is also the area of the green shape, it equals to 7 times 4 is 28. So in conclusion, it is 28 times square root of 2 square units. Or in terms of numbers, it equals to 32.6 square units. So I will repeat again, the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the first method. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we will use rule number 2. According to rule number 2, alternating angles between parallel lines are equal to each other, and we know that AB side AB is parallel to side DC because the opposite sides of a rectangle are parallel to each other. So if AB is parallel to DC, then AB will be also parallel to the part of DC, that is to say AB will be also parallel to FC, that is part of DC. So we know that AB is parallel to FC, and those two angles are defined as alternating angles, and they are located between the parallel lines AB and FC. Therefore, they are equal to each other according to rule number 2. This angle equals to theta plus theta is 2 theta. This angle equals to 2 theta. So this angle will be also equal to 2 theta. This angle equals to 2 theta according to rule number 2. I'll repeat again. Those two angles, they are alternating angles, and they are located between the parallel lines FC and AB, therefore they are equal to each other. So if this angle is equal to 2 theta, then this angle will be also equal to 2 theta. Okay, and we also know that all the angles inside the rectangle are right angles, so this angle will be equal to 90 degrees. It is a right angle. This angle, it is also a right angle, that is to say it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees. Okay? And we will define AE, side AE, we define it as x. That is to say AE equals to x according to our definition. And because of the fact that AE equals to ED according to what is given us in the question, then ED will be also equal to x. And we also know that the opposite sides of a rectangle are equal to each other. ABCD is a rectangle, so AD is equal to BC, and we know that AD equals to 2x, so BC will be also equal to 2x in its length. So in the next step, we will focus on this right triangle, triangle ABE. I will draw it again in a new page. So in the right triangle AEB, as you can see in the drawing, sinus theta will be equal to x over 7. This will be equation number 1. Sinus theta equals to x over 7. We will focus on the right triangle, right lower triangle PFC. So in this right triangle BFC, you can see from the drawing that sinus 2 theta equals to 2x over 9. Here it is 7 units and it is 9 units. We know that BF equals to 9 units and B equals to 7 units. It is given us the question. So I will repeat again. In the right triangle BFC, sinus 2 theta equals to 2x over 9. So we can write down that sinus 2 theta equals to 2x over 9. According to equation number 2. We have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosinus theta. So we actually can substitute sinus 2 theta in equation number 2 by 2 sinus theta cosinus theta according to this trigonometric identity. So we will do it now and we will get that according to equation number 2, sinus 2 theta is actually 2 sinus theta cosinus theta. And it equals to, according to equation number 2, it equals to 2x over 9, according to equation number 2. But we know that according to equation number 1, sinus theta equals to x over 7. So we can substitute sinus theta in equation number 2 by x over 7. Because it equals to x over 7 according to equation number 1. So we will do it now. 2 sinus theta equals to 2x over 7 times cosine theta, and it equals to 2x over 9. Here we have 2x on both sides of equation number 2, so 2x will get cancelled. And we will get what is left from equation number 2 after we cancel 2x. What is left, it is actually cosine theta over 7 equals to 1 over 9. We will multiply equation number 2 by 7 and we will get that cosine theta equals to 7 over 9. So we found out that according to equation number 2, cosine theta equals to 7 over 9. I will write it in a new page. Cosine theta equals to 7 over 9. So what is the meaning of cosine theta equals to 7 over 9? If we draw this function, we'll get that we have here a right triangle with one angle that equals to theta. This angle equals to theta. The hypotenuse is equals to 9 units, and the side that is near angle theta equals to 7 units, and the side that is in front of angle theta is unknown, so we will define it as S, and we will find out the value of S according to the Pythagoras theorem, that the square of the hypotenuse equals to the sum of the squares of the perpendiculars, that is to say S squared plus 7 squared equals to 9 squared. So S squared plus 7 squared is 49. Equals to 9 squared is 81. We'll subtract 49 from this equation, and we will get that S squared equals to 81 minus 49 is 32. We will take a root out of this equation, and we will get that S equals to the square root of 32. But 32 is 16 times 2, so I'll write it down. So here, the square root of 16 is 4. So we found out that S equals to 4 times square root of 2. S equals to 4 times square root of 2 units. Okay. And what is the value of sinus theta? From this drawing, you can see that the value of sinus theta is equal to 4 times square root of 2 over 9. Okay, but according to equation number 1, sinus theta equals to x over 7. So we write it down that according to equation number 1, sinus theta equals to x over 7. So we can substitute sinus theta in equation number 1 by 4 times square root of 2 over 9, because we found out that sinus theta equals to 4 times square root of 2 over 9. So we will do it now, and we will get that sinus theta is equal to 4 times square root of 2 over 9, and it equals to x over 7 according to equation number 1. We will multiply this equation number 1 by 7, and we will get that x equals to, according to equation number 1, we will get that x equals to x equals to 7 times 4 is 28. So in conclusion, x equals to 28 times square root of 2 over 9. So we can write here that x equals to 28 times square root of 2 over 9, and here also x equals to 28 times square root of 2 over 9, and AD equals to x plus x, that is to say AD equals to 56 times square root of 2 over 9, and BC also equals to 2x, that is to say it also equals to 56 times square root of 2 over 9. Here, if we focus on the right triangle, triangle ABE, you can see that cosine theta equals to AB over 7. Again, cosinus theta equals to AB over 7. Okay, cosine theta in the right triangle, triangle ABE. You can see that in the right triangle, triangle ABE, cosine theta equals to AB over 7, but we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta in this equation by 7 over 9, and it equals to AB over 7. Here we will multiply this equation by 7, and we will get that AB equals to 7 times 7 is 49 over 9. So we found out that AB equals to 49 over 9. Here we can write down that AB equals to 49 over 9. But because of the fact that the opposite sides of a rectangle are equal to each other, that is to say AB equals to DC. Okay, AB equals to DC. AB equals to DC, but we know that AB equals to 49 over 9, so DC will be also equal to 49 over 9. And we will focus on the lower right triangle, triangle BFC. On the lower right triangle, triangle BFC, you can see that cosine 2 theta equals to FC over 9. Okay, cosine 2 theta equals to FC over 9. I repeat again, on the right triangle, triangle BFC, you can see from the drawing that cosine 2 theta equals to FC over 9. We will multiply this equation by 9, and we will get that FC equals to 9 times cosine 2 theta. FC equals to 9 times cosine 2 theta. But we have the trigonometric identity that states that cosine 2 theta equals to 2 cosine theta minus 1. So we can substitute cosine 2 theta in this equation by 2 cosine squared theta minus 1. Again, according to this trigonometric identity, cosine 2 theta equals to 2 cosine squared theta minus 1. So we substitute cosine theta in this equation by 2 cosine squared theta minus 1, and we will get that FC equals to 9 times cosine 2 theta is 2 cosine squared theta minus 1. So we know that cosine theta equals to 7 over 9. If cosine theta equals to 7 over 9, then cosine squared theta will be equal to 7 over 9 squared. So we will substitute the value, we will substitute cosine theta in this equation by 7 over 9 squared. We'll do it now, and we will get that FC equals to 9 times 2 cosine squared theta equals to 7 over 9 squared minus 1. So in conclusion, we found out that FC equals to 9 times 2, 7 over 9 squared minus 1, or FC equals to 9 times 2, 7 over 9 squared is 49 over 81. And minus 1 is minus 81 over 81. So in conclusion, we got that FC equals to 9 times 2 times 49 minus 81 over 49. Two times 49 is 98, so I write it down. We will get that FC equals to 9 times 98 minus 81 over 81. Minus 81 is 17, so I write it down. We will get that FC equals to 17 times 9 over 81. Here we will divide the numerator and the denominator by 9 in this side of the equation, and we'll get that FC equals to 9 over 9 is 1, so we left only with 17. And in the denominator, we have 81 over 9 is 9. So in conclusion, we got that FC equals to 17 over 9 units. FC equals to 17 over 9 units. So we write here that FC equals to 17 over 9 units. And what is the value of DF? You can see that the value of DF from the drawing, that DC minus FC equals to DF I will repeat again. From the drawing you can see that DF equals to DC minus FC. DF equals to DC minus FC. So DF equals to DC. DC equals to 49 over 9 minus FC. FC equals to 17 over 9. So in conclusion, we found out that DF equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion, we found out that DF equals to 32 over 9. DF equals to 32 over 9. You can write here that DF equals to 32 over 9. So now we can easily find out the area of the green shape, that is also the area of trapeze ABDF, because we have all the sides of the trapeze. So the area of trapeze ABDF will be equal to the sum of its sides, that is to say to AB plus DF, times the height is AD, over 2. So I'll repeat again. The area of trapeze ABDF, that is also the area of the green shape, it equals to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. But we have already found out that AB equals to 49 over 9. DF AB equals to 49 over 9 here. DF equals to 32 over 9. Times AD, that equals to 56 times square root of 2 over 9. All divided by 2. So we found out that the area of trapeze ABDF, that is also the area of the green shape, equals to this expression. Here 49 plus 32 is 81. So I write it down. So the area of trapeze ABDF, that is also the area of the green shape, it equals to 81 over 9 times 9 times 56 times square root of 2 over 9, all divided by 2. So here 9 times 9 is 81, and 81 over 81 is 1, so this expression will get cancelled, and we left only with 56 over 2 is 28. So we found out that the area of trapeze ABDF, that is the area also of the green shape, it equals either to 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. I will repeat again. According to the second method, the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. So we finished with the second method. In the next step, I will present to you how to find out the area of this green shape according to the third method. Here we will do a construction. We will draw perpendicular from point E to BF, to side BF. So this angle will be equal to 90 degrees. It is a right angle. And this angle will be also equal to 90 degrees. It is also a right angle. We will define the touching point between the perpendicular from E to BF as point M. And we know that all the angles inside a rectangle are right angles, so this angle, it is a right angle, that is to say it equals to 90 degrees. And this angle, it is also a right angle, that is to say it equals to 90 degrees, and this angle, it is also a right angle, it is equals to 90 degrees. So in the next step, we will prove that those two right triangles can congruent to each other. Okay, so we will prove that the right triangle, triangle AEB, this right green triangle, congruent to the right green triangle, triangle BEM, this right triangle. First of all, you know that those two angles they are equal to each other. So angle ABE, this angle, is equal to this angle, angle EBM, this angle. and both those two angles are equal to theta according to what is given us in the question. So we can write down that angle ABE equals to angle EBM, and both those two angles are equal to theta according to what is given us in the question. And we also know that those two angles, they are equal to each other, they are both right angles, so we can write down that angle EAB, this angle, is equal to angle EMB, this angle, and they are both equal to 90 degrees, so I'll repeat again, angle EAB equals to angle EMB, and they are both equal to 90 degrees. They are right angles. And those two angles, they are also equal to each other according to third angle theorem. So this angle, angle AEB, is equal to this angle, angle BEM. And they are equal to each other according to third angle theorem. I repeat again, angle AEB equals to angle BEM, and they are equal to each other according to third angle theorem. So what is third angle theorem? Third angle theorem states that if two angles in one triangle congruent to two angles in another triangle, then the third pair of angles must also congruent. So here we have those two angles in the right triangle, triangle ABE, congruent to those two angles in the right triangle, triangle EBM. So we have two pairs of angles that congruent in those two triangles, therefore the third pair of angles, those two angles that are defined as the third pair of angles, must also congruent, that is to say, angle AEB equals to angle BEM. Okay? And we also know that EB is a common side, that is to say it belongs to both triangles. So EB equals to EB is a common side that belongs to both triangles. So EB equals to EB is a common side that belongs to both triangles. So we actually proved that those two triangles congruent to each other according to side-angle rule. Why? Because we have those two angles, those two angles, and the side between them, that is to say side EB in the right green triangle, triangle ABE, congruent to those two angles, and the side between those two angles, that is to say EB, in the right triangle, triangle EBM. Therefore, those two right triangles congruent to each other according to side-angle rule. So write down that triangle AEB, is congruent to triangle BEM according to angle side angle rule. Okay, triangle AEB congruent to triangle BEM according to angle side angle rule. And from the fact that those two triangles congruent to each other, we will conclude that AB equals to BM. AB equals to BM. According to the rule that corresponding sides in congruent triangles are equal to each other, and if we define AB as y, that is to say AB equals to y according to our definition, then BM will be also equal to y because they are equal to each other. So AB equals to BM equals to y according to our definition, and we will also conclude from the fact that those two triangles can go into each other that AE equals to EM according to the same rule that corresponding sides in congruent triangles are equal to each other. And if we define AE as x, then EM will be also equal to x. If we define AE as x, then EM will be also equal to x because they are equal to each other. Okay? And here we know that BF equals to 9 units and BM equals to y. So MF equals to BF minus BM, that is to say MF equals to BM, that is 9 units, minus MF, that is y. So in conclusion, we found out that MF equals to 9 minus y. In the next step, we will join together points E and F by a straight line. And we will prove that those two right triangles can go into each other. Okay? We will prove the triangle EDF, this right triangle, congruent to this triangle, triangle EFM. So why they congruent to each other? They congruent to each other because of the fact that first of all, EM, we know that AE equals to ED. You can see it is given us in the question that AE equals to ED. But AE equals to X. So AD will be also equal to X. Okay, because of the fact that AE equals to ED and AE equals to X, therefore ED must be also equal to X. So here we see that EM equals to ED equals to X. EM equals to ED equals to X. Okay, EM equals to ED equals to X. And we have also a common side. EF is a common side. It is a hypotenuse that belongs to both triangles. So EF equals to EF is a common side that belongs to both triangles. This is the hypotenuse that belongs to both triangles. EF equals to EF is a common side that belongs to both triangles. I repeat again. EF equals to EF is a common side that belongs to both triangles. And we also have those two angles that are equal to each other. They are both right angles. So angle EDF of triangle EDF is equal to angle EMF, this angle, and they are both equal to 90 degrees. I'll repeat again. Angle EDF equals to angle EMF, and they are both equal to 90 degrees. They are right angles. So by proving those three things, we actually proved that triangle EDF is congruent to triangle EFM according to rule number 5. What is rule number 5? Rule number 5 states that if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. I will repeat again on rule number 5. According to rule number 5, if the hypotenuse and the perpendicular in two right triangles congruent, then the triangles congruent to each other. So here we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF congruent to the same hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles congruent to each other according to rule number 5. Okay, so we can write down the triangle EDF. Triangle EDF congruent to triangle EFM according to rule number 5. Okay, triangle EDF congruent to triangle EFM according to rule number 5, and from the fact that those two triangles congruent to each other, we will conclude that DF equals to MF. DF equals to MF. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other. Therefore, according to rule number 5. Therefore, the two corresponding sides, that is to say DF and MF, will be equal to each other. That is to say DF equals to MF, but we have already found out that MF equals to 9 minus Y. So we can write down that MF equals to 9 minus Y. And from this equality we will conclude that DF also equals to 9 minus Y. Here we found out that DF equals to 9 minus Y. And we also know that the opposite sides of a rectangle are equal to each other. Okay, the opposite sides of a rectangle are equal to each other, that is to say AB is equal to DC. But AB equals to Y, therefore DC will be also equal to Y. So DC equals to Y. And what is the value of FC? You can see from the drawing that DC minus DF equals to FC. So DC minus DF equals to FC. I repeat again, from the drawing you can see that DC minus DF equals to FC. Okay, FC equals to DC minus DF. So actually FC equals to DC is Y minus DF is 9 minus Y. So we found out that FC equals to Y minus 9 minus Y. We will open the brackets here and we will get that FC equals to Y minus 9 minus Y is plus Y. So in conclusion we found out that FC equals to 2Y minus 9. FC equals to 2Y minus 9. So we can write here that FC equals to 2Y minus 9. And we know that the opposite sides of a rectangle are equal to each other. That is to say AD equals to BC. But AD equals to x plus x. That is to say AD equals to 2x. Therefore BC will be also equal to 2x. So here we will focus on this right triangle, triangle AEB. On the right triangle, triangle AEB, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So we will get that x squared plus y squared equals to 7 squared, that is to say to 49. So we found out that in the right triangle, triangle AEB, according to equation number 1, x squared plus y squared equals to 49. In the next step we will focus on the right triangle, triangle BFC. On the right triangle, triangle BFC, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle BFC is BF, and we know it is given us the question that BF equals to 9 units. So BF square will be equal to 9 square. 9 square is 81. So 81 equals to the sum of the squares of the perpendiculars. That is to say, it equals to FC square plus BC square. So we found out that in the right triangle BFC, according to the Pythagoras theorem, 81 equals to FC square plus BC square. But we have already found out that FC equals to 2y minus 9, therefore FC square will be equal to 2y minus 9 square plus BC square. BC equals to 2x, so BC square will be equal to 2x square. 2x square is 4x square. So in conclusion, we found out that 81 equals to 2y minus 9 square plus 4x square. We will open the brackets here. 2y minus 9 square, it is actually equals to 4y square plus 81 minus 36y plus 4x square. Here we have 81 on both sides of equation number 2, so 81 will get cancelled, and what is left from equation number 2 after we cancelled 81, what is left is, it is actually 0, equals to 4 will be a common factor of 4x square plus 4y square, so inside the brackets we will have x square plus y square minus 36y. We will add 36y to this equation, equation number 2, and we will get that 36y equals to 4 times x square plus y square. X square plus y square, according to equation number 1, is equal to 49. So we can substitute x square plus y square in equation number 2 by 49 from equation number 1. Because x square plus y square equals to 49, so we will get that, according to equation number 2, 36y equals to 4 times, and x square plus y square is 49 according to equation number 2, so according to equation number 1, this equation, so x square plus y square is 49. So we got here that 36y equals to 4 times 49. We will divide this equation number 2 by 4, and we will get that 36y over 4 is 9y, and it equals to 4 over 4 is 1, so we left only with 49. So we found out that 9y equals to 49. We will divide this equation number 2 by 9, and we will get that, according to equation number 2, y equals to 49 over 9. And according to equation number 1, we found out that x squared plus y squared equals to 49. So here, in equation number 1, we can substitute y squared by 49 over 9 squared, because according to equation number 2, y squared equals to 49 over 9. Okay, so we'll do it now, and we will get that x squared plus y squared according to equation number 2 is 49 over 9 squared. It equals to 49. So we will subtract 49 over 9 square from this equation number 1, and we will get that x squared equals 49 is 7 square minus 49 over 9 square So here we will use the algebraic identity that a squared minus b squared equals to a plus b times a minus b in order to simplify this equation number 1. So we will use the algebraic identity that states that a squared minus b squared equals to a plus b times a minus b, and in our specific equation number 1, we know that b squared equals to 0, a equals to 7, and b equals to 49 over 9. So in conclusion, we will get that according to this trigonometric algebraic identity that x squared is equal to a plus b is 7 plus 49 over 9 times a minus b is 7 minus 49 over 9. So here we will multiply 7 by 7 by 9, and then we will divide it by 9 in order to have a common factor over 49 over 9, and we will get that 7 times 9 is 63 plus 49 over 9 times 63 minus 49 over 9 equals to x squared. 63 plus 49 is 112 over 9. 63 minus 49 is 14 over 9. 112 is 8 times 14, so we substitute 112 by 8 times 14 in equation number 1, and we will get that according to equation number 1, x squared equals to 112 is 8 times 12, 8 times 14, times 14 over 9 times 9. So we got that x squared equals to and repeat again, we substituted 112 by 8 times 14 and we got this expression. Here 8 is 2 times 2 times 2, so we will substitute 8 by 2 times 2 times 2, and we will get that x squared according to equation number 2 equals to 2 times 2 times 2 times 14 times 14 over 9 times 9 over 9 times 9. So here we'll take a root out of this equation number 1, and we will get that x equals to the square root of 2 times 2 times 2 times 14 times 14 over 9 times 9. So actually the square root of 2 times 2 is 2, the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9, and inside the root we left only with 2, so in conclusion we found out that x equals to 2 times 14 over 9 times square root of 2, and 2 times 14 is 28 times square root of 2 over 9. So we found out that x equals to 28 times square root of 2 over 9. Now we can easily find out the area of the green shape, that is actually the area of trapeze ABDF. The area of any trapeze, the formula for the area of any trapeze, and especially trapeze, this trapeze ABDF, it equals to the sum of its sides, that is to say AB plus DF, times the height, that is AD, over 2. So the area of trapeze ABDF, that is also the area of the green shape, it equals to AB plus DF times AD over 2. But we have already found out that AB equals to Y. And DF equals to 9 minus Y. And AD equals to x plus x, that is to say it equals to 2x over 2. So in conclusion, we found out that the area of trapeze ABDF, that is also the area of the green shape, equals to this expression, and y plus y minus y minus y is 0, and 2 over 2 is 1. So in conclusion, we found out that the area of trapeze ABDF equals to, this is also the area of the green shape, equals to 9x. But we have already found out that x equals to 28 times square root of 2 over 9. So we can put the value of x inside x here, and we will get that 9 times x, and x is 22 times square root of 2 over 9. Here 9 over 9 is 1, so 9 will get cancelled, and we found out that the area of the green shape, it equals to either 28 times square root of 2 square units, according to the third method, or it equals to 39.6 square units. I will repeat again. We found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 32, it equals to 39.6 square units. So now I will summarize the lecture. Actually, we found out the area of this green shape according to 3 methods. in the first method, we did a construction we extended side CD and side BE until they intersect with each other at point P. We know that CD is a straight line, therefore CP that is on the same straight line of CD, we extended the straight line CD by a straight line, so CP will be still a straight line. And we have rule number 1. So we know that PC is a straight line, and we have rule number 1 that states that the sum of the angles on one side of a straight line is equal to 180 degrees. So actually, if we focus on this side of the straight line PC, at point D, the sum of the angles must be equal to 180 degrees. That is to say, this angle that is defined as angle X plus this angle that is a right angle must be equal to 180 degrees. X plus 90 degrees equals to 180 degrees according to rule number 1. We subtracted 90 degrees from this equality, and we found out that angle X equals to 90 degrees. So we found out that this angle is a right angle, is equals to 90 degrees. And here we know that CP is one straight line, and if AB is parallel to CD, we know that the opposite sides of a rectangle are parallel to each other. So if AB is parallel to the straight line CD, then AB will be also parallel to PC, because PC and CD are located on the same straight line. So if AB is parallel to the straight line CD, AB will be also parallel to the same straight line PC. So we know that AB is parallel to PC. And we have rule number 2, so we know that AB is parallel to PC, and according to rule number 2, alternating angles between parallel lines are equal to each other. So we have those two angles are defined as alternating angles, and they are located between the parallel lines AB and PC, therefore they are equal to each other according to rule number 2. So according to rule number 2, angle ABE is equal to angle DPE, because of the fact that those two angles are defined as alternating angles, and they are located between the parallel lines AB and PC, therefore they are equal to each other. But we know that AB equals to theta. It is given us the question that angle ABE equals to theta. So from this equality we will get that angle DPE also equals to theta. So this angle also equals to theta. Then we proved that those two right angles can go into each other, can go into each other. Because of the fact that angle AB equals to angle APD equals to theta, we just right now proved that those two angles are equal to each other, and they are both equal to theta. We also know that those two angles, they are both right angles, therefore they are equal to each other. That is to say, angle BAE equals to angle EDP equals to 90 degrees. And we also know that those two angles, they are equal to each other according to the rule that vertex angles are equal to each other. Angle AEB equals to angle PED according to the rule that vertex angles are equal to each other, and they are defined as vertex angles, therefore they are equal to each other. And we know that AE equals to ED according to what is given us the question, that AE equals to ED. It's given us the question that AE equals to ED. So we actually proved that triangle ABE is congruent to triangle PED according to angle side angle rule. So what is angle side angle rule? Angle side angle rule is that if two angles and the side that included between those two angles in one triangle can coend correspondingly to two angles in the side that included in another triangle, then the triangles can coend to each other according to angle side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is to say AE, correspondingly can coend to those two angles and the side that included between those two angles, that is to say ED, in triangle PED. Therefore, we proved that those two triangles, those two right triangles can coend to each other according to angle side angle rule. And from the fact that those two triangles can coend to each other, we will conclude that BE equals to EP, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can coend to each other, therefore the corresponding sides, that is to say BE and EP, will be equal to each other. But we know that BE equals to 7 units. It is given us in the question, BE equals to 7 units. So from this equality we will conclude that EP also equals to 7 units, so EP equals to also to 7 units. Then we defined quadrilateral EBFD, the area of quadrilateral EBFD is Y. That is to say the area of triangle EBFD is defined as Y, and define the area of triangle, define the area of the right green triangle ABE as X. So the area of triangle ABE is defined as X. And we know that the green shape equals, the area of the green shape equals to X plus Y. The area of the green shape equals to X plus Y. But because of the fact that the area of these right triangles, but because of the fact that those two right triangles can coend to each other, they also have the same areas. So if the area of triangle ABE is X, then the area of triangle PED must be also equal to X. So in the triangle PBF, the area of triangle PBF is equal also to X plus Y. So you can see that the area of triangle PBF equals to X plus Y exactly as the area of the green shape. So we can find out the area of triangle PBF, and in this way we will find out that the area of the green shape that is also exactly the same area. And we know that the area triangle PBF is an isosceles triangle. Why? Because it has two angles that are equal to each other. They are both equal to theta. So triangle PBF is an isosceles triangle. And we have rule number 3 that relates to isosceles triangles. According to rule number 3, the median to the base of an isosceles triangle is perpendicular to the base. So what is the meaning of rule number 3? The meaning of rule number 3 is that if we have an isosceles triangle ABC is an isosceles triangle. Why? Because it has two angles that are equal to each other. They are both equal to theta. So in this isosceles triangle, the base is BC. And so if we draw median to the base BC, that median bisects the base BC into two equal parts. That is to say BO equals to OC equals to X. But according to rule number 3, it is not only bisects the base BC into two equal parts, but it is also perpendicular to the base BC. That is to say this angle is equal to 90 degrees and this angle is equal to 90 degrees. So whenever you have an isosceles triangle and you draw median to the base, then that median will be perpendicular to that base. So we can implement rule number 3 in our drawing, because in our drawing we have the isosceles triangle PBF and the median is FE. So according to rule number 3, the median FE is not only bisects the base PB into two equal parts, but it is also perpendicular to the base PB. That is to say this angle equals to 90 degrees and this angle also equals to 90 degrees. And because of the fact that this angle is equal to 90 degrees, then triangle BEF is a right triangle. So we can implement the Pythagoras theorem in the right triangle BEF. According to the Pythagoras theorem, in the right triangle BEF, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is BF, so the square of the hypotenuse is BF square, and it equals to the sum of the squares of the perpendiculars. That is to say, it equals to EB square plus EF square. BF equals to 9 units. This is giving us the equation. So BF square is 9 square, 9 square is 81. BE equals to 7 units, so BE square is 7 square, 7 square is 49. EF square is the missing variable. We subtracted 49 from this equation number 1, and we got that 81 minus 49 is 32. So we got that 32 equals to EF square. We took a root out of this equation number 1, and we got that EF equals to the square root of 32. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that EF equals to 4 times square root of 2 units. EF equals to 4 times square root of 2 units. So we can now easily find out the area of the isosceles triangle PBF. The area of the isosceles triangle PBF equals to the base of the triangle times the height to the base over 2. The base is PB, the height is EF, so the area of triangle PBF equals to the base BP times the height EF over 2. The base PB is equal to 7 plus 7, that is to say it equals to 14 units, and the height is 4 times 2. So in conclusion, we found out that the area of the isosceles triangle PBF equals to 14 times 4 times square root of 2 over 2. 14 over 2 is 7, so in conclusion, we found out that the area of the isosceles triangle PBF equals to 7 times 4 times square root of 2, and the area of the isosceles triangle PBF is also the area of the green shape. So we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, the area of the green shape equals to 39.6 square units. So we finished with the first method. Then I presented to you how to find out the area of this green shape according to a second method. In the second method, we actually use rule number 2, that alternating angles between parallel lines are equal to each other. We know that AB is parallel to DC because of the fact that the opposite sides of a rectangle are parallel to each other. But if AB is parallel to DC, then AB will be also parallel to part of BC, to the part of DC. That is to say, AB will be parallel to FC, so we know that AB is parallel to FC. Therefore, according to rule number 2, that those two alternating angles that are located between the parallel lines AB and FC will be equal to each other. That is to say, this angle equals to this angle, but this angle ABF equals to 2 theta, so this angle will be also equal to 2 theta because of the fact that those two angles are equal to each other. So this angle BFC equals to 2 theta, and we know that all the angles inside a rectangle are right angles, so those 1, 2, 3 angles are right angles. Also this angle, of course. And we focus on this right triangle ABE, and I do this triangle again. And in this right triangle ABE, right triangle ABE, sinus theta equals to x over 7. This is equation number 1. And in the right triangle BFC, and the lower right triangle BFC, first of all, we know that AD equals to BC because of the fact that the opposite sides of a rectangle are equal to each other. So if AD equals to x plus x, that is to say AD equals to 2x, then BC will be also equal to 2x. And sinus 2 theta will be equal to 2x over 9 in the right triangle BFC. So we found out that in the right triangle BFC, sinus 2 theta equals to 2x over 9, but we have the trigonometric identity that sinus 2 theta equals to 2 sinus theta cosine theta, so we can substitute sinus 2 theta by 2 sinus theta cosine theta according to this trigonometric identity. So we did it and we got that according to equation number 2, 2 sin theta cosine theta equals to 2x over 9. And according to equation number 1, sine 2 theta equals to x over 7, so we can substitute sine theta in this equation number 2 by x over 7. We did it and we got that 2x over 7 times cosine theta equals to 2x over 9. We have 2x in both sides of equation number 2, so 2x will get cancelled and be left only with cosine theta over 7 equals to 1 over 9. We multiply this equation number 2 by 7, and we got that cosine theta equals to 7 over 9. So we found out that cosine theta equals to 7 over 9. So here we know that cosine theta equals to 7 over 9. What is the meaning that cosine theta is equal to 7 over 9? It means that we have a right triangle with hypotenuse that equals to 7 units, and the side that is near angle theta, it equals to 7 units, and the only missing side that is the side that is in front of angle theta. We defined it as S, and according to the Pythagoras theorem, 7 square plus S square equals to 9 square, S square plus 7 square equals to 9 square. So S square equals to 7 square is 49, 9 square is 81. We subtracted 49 from this equation. 81 minus 49 is 32, so we got that S square equals to 32. We took a root out of this equation and we got that S equals to square root of 32. 32 is 16 times 2, and the square root of 16 is 4. So in conclusion, we found out that S equals to 4 times square root of 2. Here S equals to 4 times square root of 2. Then we have, so we can find here, from here we can see that sinus theta equals to 4 times square root of 2 over 7, or 4 times square root of 2 over 9. Sin theta, from this drawing you can see that it equals to 4 times square root of 2 over 9. But according to equation number 1, sin theta equals to x over 7. So we can substitute sin theta in this equation number 1 by 4 times square root of 2 over 9. We did it and we got that 4 times square root of 2 over 9 equals to x over 7. We multiplied this equation number 1 by 7, and we got that x equals to 7 times 4 times square root of 2 over 9. 7 times 4 is 28. So in conclusion, we found out that x equals to 28 times square root of 2 over 9 units. So we can write here that x equals to 28 times square root of 2 over 9, and also here x equals to 28 times square root of 2 over 9, and AD equals to x plus x, that is to say AD equals to 2x. 2x is 56 times square root of 2 over 9, and we know that the opposite sides of a rectangle are equal to each other. So here 2x also equals to BC equals to 2x, that is to say it equals to 56 times square root of 2 over 9. Then we focus on this right triangle BAE. You can see here that cosine theta equals to AB over 7. So here you can see that cosine in this right triangle ABE, cosine 2 theta equals to AB over 7, but we have already found out that cosine theta equals to 7 over 9, so we can substitute cosine theta by 7 over 9. We did it and we got that 7 over 9 equals to AB over 7. We multiplied this equation by 7 and we got that AB equals to 49 over 9, because 7 times 7 is 49, so AB in conclusion is equal to 49 over 9. So we can write here that AB equals to 49 over 9. But because of the fact that the opposite sides of a rectangle are equal to each other, it means that AB equals to DC. So if AB equals to 49 over 9, then DC also equal to 49, will be equal also to 49 over 9. Then in triangle BFC, this lower right triangle, we know that cosine 2 theta equals to FC over 9. Cosine 2 theta equals to FC over 9. We multiplied this equation by 9 and we got that FC equals to 9 times cosine 2 theta. According to the trigonometric identity, cosine 2 theta equals to 2 cosine square theta minus 1. So we can substitute cosine 2 theta in this equation by 2 cosine square theta minus 1. We did it and we got that FC equals to 9 times 2 cosine square theta minus 1. We know that cosine theta equals to 7 over 9, therefore cosine square theta will be equal to 7 over 9 square, so we can substitute cosine square theta here by 7 over 9 square. So here we did it and we got that f equals to 9 times 2 and cosine square theta equals to 7 over 9 square minus 1, so we got that f equals to 9 times 2, 7 over 9 square is 49 over 81. So we got that f equals to 9 times 2 times 49 over 81, and minus 1 is 81 minus 81. So here we know that 2 times 49 is 98, so in conclusion we got that f equals to 9 times 98 over 81, 98 minus 81 over 81. 98 minus 81 is 17, so in conclusion we got that f equals to 90 times 17 over 81. Here we divided the numerator and the denominator by 9, and we got here that f equals to 9 over 9 is 1, so we left only with 17 with the numerator, and in the denominator we have 81 over 9 is 9, so in conclusion we found out that f equals to 17 over 9. Here we can write down that f equals to 17 over 9. And what is the value of df? df equals to dc minus fc. Okay, df equals to dc minus fc. So df equals to dc is 49 over 9 and fc is 17 over 9. So in conclusion we got that df equals to 49 over 9 minus 17 over 9. 49 minus 17 is 32. So in conclusion we found out that df equals to 32 over 9. Here df equals to 32 over 9. So we have here all the sides of the green shape, that is also all the sides of trapeze ABDF, so we can easily find out the area of this trapeze ABDF. The area of trapeze ABDF equals to the sum of its sides, that is to say AB plus DF times the height AD over 2. We have already found out that AB equals to 49 over 9, DF equals to 32 over 9, and AD equals to 56 times square root of 2 over 9, all divided by 2. 49 plus 32 is 81. And in the denominator we have 9 times 9. 9 times 9 is 81, and 81 over 81 is 1, so this expression will get cancelled, and we left only with 56 times square root of 2 over 2. 56 over 2 is 28, so in conclusion we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay? We finished with the second method. Then I presented to you how to find out the area of this green shape according to third method. According to the third method, we actually did a construction. Actually, from point E, we drew perpendicular to BF. We define the touching point between the perpendicular from E to BF as point M. So this angle equals to 90 degrees and this angle also equals to 90 degrees. And we proved that those two right triangles can go into each other. Why they can go into each other? Because actually, first of all, we know that angle AB equals to angle EBM equals to theta. Those two angles, they are equal to each other and they are both equal to theta. And we also know that those two angles, they are both right angles, therefore they are equal to each other. So angle EAB equals to angle EMB equals to 90 degrees. And here, those two angles are also equal to each other according to third angle theorem. Angle EAB equals to angle EBM equals to, they are equal to each other according to third angle theorem. What is third angle theorem? Third angle theorem is that if two angles in one triangle can go into two angles in another triangle, then the third pair of angles must also congruent. We have those two angles in triangle BAE congruent to those two angles in triangle BEM. Therefore, we have two pairs of angles that are congruent in those two triangles. Therefore, the third pair of angles must also congruent. That is to say, angle BEM must also be equal to angle AEB. Okay? So angle AEB must be equal to angle EBM according to further angle theorem, and also EB equals to EB. EB is a common side that belongs to both triangles. So EB equals to EB is a common side. So we actually proved that triangle AEB is congruent to triangle BEM according to angle side angle rule. Okay, we proved that those two angles and the side between them, that is to say side BE, in this triangle ABE, is congruent to those two angles, and the side between them, that is to say side EB, in this right triangle EBM. Therefore, we proved that those two triangles congruent to each other according to angle side angle rule. Triangle AEB is congruent to angle BEM according to angle side angle rule. From the fact that those two triangles congruent to each other, we will conclude that EM equals to ED, EM equals to ED, EM equals to ED, here EM equals to ED, EM equals to ED, EM equals to ED, and if ED equals to X, then EM will be also equal to X, and EF equals to EF. It is a common side that belongs to both triangles, and angle EDF equals to angle EMF equals to 90 degrees. So those two angles are equal to each other. They are both equal to 90 degrees. And actually here we proved that those two right triangles can go into each other according to angle side angle rule. And therefore, because of the fact that those two right triangles can go into each other, we will conclude that AB is equal to BM. But if AB will be equal to Y according to our definition, then BM will be also equal to Y because they are equal to each other. And actually MF equals to BF minus BM, and BF is 9 units and BM is Y, so MF equals to 9 minus Y. Okay, then we join together those points E and F by straight line, and we proved that those two right triangles can go into each other. Why they can go into each other? Why they can go into each other? Because of the fact that, first of all, we know that EM equals to ED equals to X, EM equals to ED equals to X, and EF equals to EF. It is a common side that belongs to both triangles. And here those two angles, the right angles, therefore they are equal to each other. So angle EDF equals to angle EMF equals to 90 degrees. Therefore, we actually proved that those two right angles can go into each other according to rule number 5. What is rule number 5? Rule number 5 says that if the hypotenuse and the perpendicular in two right triangles can go in, then the triangles can go into each other. And we actually proved that the hypotenuse EF and the perpendicular ED in the right triangle EDF can go into the same hypotenuse EF and the perpendicular EM in the right triangle EMF. Therefore, we proved that those two right triangles can go into each other according to rule number 5. Okay, we proved that triangle EDF can go into triangle EMF according to rule number 5. From the fact that those two triangles can go into each other, we will conclude that DF equals to MF. DF equals to MF, but we know that MF equals to 9 minus Y. MF equals to 9 minus Y, so from this equality we will conclude that DF also equals to 9 minus Y. DF also equals to 9 minus Y. And we know that the opposite sides of rectangle are equal to each other, that is to say AB equals to DC. But AB equals to Y, so DC will be also equal to Y. And we know that DF equals to 9 minus Y. So what is the value of CF? CF will be equal to DC minus DF. So here CF or FC equals to DC minus DF. We already found out that DC equals to Y and DF equals to 9 minus Y. So FC equals to Y minus 9 minus Y. We open the brackets and we got that FC equals to Y minus Y is plus Y, so minus 9. So in conclusion, we found out that FC equals to 2Y minus 9. Here FC equals to 2Y minus 9, and here AB equals to BC, so if AB equals to 2x, then BC will be also equal to 2x. And in this right triangle, according to the Pythagoras theorem, x squared plus y squared equals to 49. Here x squared plus y squared equals to 49, according to equation number 1, in the right triangle EBM. In this right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, FB squared is 9 squared, 9 squared is 81, and it equals to FC squared plus BC squared. 81 in the right triangle BFC, 81 equals to FC squared plus BC squared. So 81 equals to FC is 2y minus 9, so FC squared will be equal to 2y minus 9 squared. BC is 2x, so BC squared will be equal to 4x squared. And here we open the brackets here into y minus 9 squared. So in conclusion, we got that 81 equals to 4y squared plus 81 minus 46y plus 4xy, 4x squared. We have 81 on both sides of this equation, so 81 will get cancelled. So in conclusion, we got that 81 equals to 4 is a common factor. Inside the brackets, we have x squared plus y squared minus 36y. So 36y is equal to 4 times x squared plus y squared. We divided this equation by 4 and we got actually x squared plus y squared according to equation number 1 equals to 49. So we can substitute x squared plus y squared in equation number 2 by 49. We did it and we got that 36y equals to 4 times 49. We divided this equation by 4 and we got that 36y over 4 is 9y and 4 over 4 is 1, so we left in this side only for 49. We got that 9y equals to 49. We divided this equation number 2 by 9 and we got that y equals to 49 over 9. But according to equation number 1, x squared plus y squared equals to 49. So we can substitute y squared in this equation number 1, by 49 over 9 squared, because 49 over 9 squared equals to y squared. So we did it, and we got that x squared equals to y squared is 49 over 9 squared. It equals to 49. We got that x squared equals to 49 is 7 squared. We subtracted 49 over 9 squared from this equation number 1, and we got that x squared equals to 7 squared minus 49 over 9 squared. We have we used the algebraic identity that x squared minus b squared equals to a plus b, a minus b. Here b squared is 0, a equals to 7, and b equals to 49 over 9. So according to this trigonometric identity, a squared minus b squared, that is x squared, is equal to a plus b. A plus b is 7 plus 49 over 9, and a minus b is 7 minus 49 over 9. So we got that x squared, we multiplied 7 by 9, and then we divided by 9 in order to overcome the factor with 49 over 9. And we got that x squared equals to 63 plus 49 over 9. And here is 63 minus 49 over 9. 63 plus 49 is 112. And 63 minus 49 is 14. So in conclusion, we got that x squared equals to 112 over 9 times 14 over 9. 112 is 8 times 14, so we substituted 112 by 8 times 14. And we got that x squared equals to 8 times 14 times 14 over 9 times 9. 8 is 2 times 2 times 2, so we substituted 8 by 2 times 2 times 2. And we got that x squared equals to 2 times 2 times 2 times 14 over 9 times 9. We took out of this equation number 1, and we got that x equals to this expression. The square root of 2 times 2 is 2, and the square root of 14 times 14 is 14, and the square root of 9 times 9 is 9. So in conclusion, we got that x equals to 2 times 14 times square root of 2 over 9, or x equals to 2 times 14 is 28. So in conclusion, we got that x equals to 28 times square root of 2 over 9. Then we note that the area of any trapezoid is equals to the sum of its sides. That is to say, it equals to AB plus DF times the height, that is AD over 2. So the area of trapezoid ABDF equals to AB plus DF times AD over 2. AB is y and DF is 9 minus y. AD is 2x, all divided by 2. So y minus y is 0, and 2 over 2 is 1. So in conclusion, we got that the area of trapezoid ABDF, that is also the area of the green shape, equals to 9x. So 9x, and we already found out that x equals to 28 times square root of 2 over 9. So 9 over 9 is 1. So in conclusion, we found out that the area of the green shape equals to either 28 times square root of 2 square units, or in terms of numbers, it equals to 39.6 square units. Okay, thank you very much.